Alright, I think we might be streaming again. Doing all the usual checks. Welcome back, everyone. We are live on twitch.tv/scanlime, on the Scanlime-in-progress YouTube channel, and on our friendly local host hangout here, live.diode.zone/scanlime. So, welcome back. This is a bit of a continuation in a mini self-contained series on some kind of camera modification stuff I've been doing for the isopod stream around here. So it's sort of another weird side project because I'm great at procrastinating the long-term projects with little projects like this sometimes. But it's been pretty satisfying. This has been a combination of doing some kind of easy CAD work, some hard CAD work, and just downloading some stuff and printing it, and just buying some lenses. So it's been pretty satisfying for what it is. Happy Friday, folks. I think we've got Tuco on camera too. Maybe we can get a better view. And sort of, you can sort of see me. He likes that heating pad. It's kind of warm. Oof, yeah, I'm sorry about the bad news about Simone. That really sucks. Just saw that now in chat. Ah, man. So many downsides to being a human. But I don't know, I've been in that depression rut lately, and sometimes just working on a weird project kind of helps, so. So here we are again, Tuco in the little box, me in the big box. Sometimes we switch places. Sometimes we both hang out underneath the monitor and Tuco gets to be servo AF and I get to have my head blocked by the exposure meter. I get questions about that overlay sometimes. Some people think I guess I just do it because it looks distinctive, but it's mostly because this camera doesn't give me like a clean high-res HDMI output. And it also turns off the normal viewfinder and controls when I'm using it in this mode. So, until I upgrade the camera, basically, I have to show you the viewfinder rather than showing you the actual HD video necessarily. All right. This little critter here on the desk is a Logitech C920 camera, which some of you might know about. It's a pretty popular camera because it's not that inexpensive, actually. You can get much cheaper webcams now. I think buying one new is still going to set you back like 50 bucks. Part of that is the Logitech brand name. But part of it is that while a lot of these cameras that you might get really inexpensively, they have these USB interfaces that are kind of usually there's some fairly high volume chip without any kind of customization, like maybe one of the OmniVision chips or something, or maybe some Chinese chip that I don't know about that serves a similar purpose. And the board as a whole doesn't necessarily have great image processing or compression, and compression is necessary for sending video over USB 2, unless you're happy with just 640 by 480, which is what a lot of the really cheap cameras limit you to. Whereas the Logitech C920 is decent for actual HD broadcasting. That's what this camera is right now. Actually, some of you requested a mirror for seeing the cameras. It's actually a pretty good idea for illustration. So that's a Logitech C920 with gaff tape around the edges just to block some of the studio lights from it. Let me show you this one too. Yeah, that one's the flying camera with lasers. It's fancy. We've been building that as kind of a long-term project. It still needs work, like most of the long-term projects, but it's plenty usable, so we've been plenty using it. Yeah, so this camera on the desk was actually a secondary C920 that I was using for broadcasting. I was briefly attempting to do video editing streams, but so far I haven't found a good way to do that. They just are too meta and too time-consuming and too depressing. So I tried using a spare C920 camera over on my desk for that, and it wasn't great, so I'm just repurposing it. And this turned into a somewhat heavy-duty modification. The two main modifications that we've done on the C920 here, other than just transplanting it into a new box, are actually removing the autofocus lens assembly. So the C920 has autofocus. It's actually got a pretty good multi-element lens with a very delicate coil assembly that moves the lens elements up and down in response to some voltage from the system on chip here. Yeah, so I hadn't mentioned the system on chip actually. So this actually has some kind of Logitech branded camera chip which does additional processing, and I don't know the full extent of what they're doing in there, but it's capable of at least real-time H.264 and MJPEG compression at pretty good quality, and seems to have much better color processing than a lot of these really cheap webcams. It also has some DC to DC converters that don't overheat, which also some of the little webcams just have a really overloaded linear regulator that's prone to overheating. I was having that problem on one of my isopod cameras. So yeah, it's a good camera base to use. Yeah, you kind of have to take off some features that you don't want necessarily. So if you don't want, I mean, I tried actually putting other lenses in front of the autofocus module, and that didn't work super well. I just wasn't really getting the field of view or the sharpness that I would want. I tried using like cell phone adapter lenses and DSLR adapter lenses. I could have done a much better job on mounting them. The mounts were very haphazard, but I didn't really pursue doing a better job mounting the adapters once I noticed that, you know, like there was a pretty big community around modifying this camera, and all of them just seemed to desolder the autofocus lens. So that's what I did too. Saved that for a rainy day in case we want to experiment with an autofocus lens in a different context. But for now, the circuit board here just has nothing connected to those pads, so the focus controls won't do anything. And we can focus it just like a regular fixed focus cam by twisting the lens. And then the next difficulty is that the C920 does not use a standard lens mount diameter. 20 millimeters and 18 millimeters are both pretty common for these 12 millimeter lenses. But I forget the number off the top of my head. I think the C920, it's more like 16 millimeters, but it's not even a round number. So I was going to have to design something special. I temporarily mounted it just using some hot glue, but I got the focus plane completely not accurate, so it was a little fuzzy. But yeah, that was enough to kind of give me some confidence that this approach would work. So then I found this 3D model helpfully on Thingiverse, which I linked to in my GitHub for this now. And that one actually has this nicely designed adapter that just fits the circuit board perfectly, and it doesn't expect you to 3D print M12 threads. That would be a little crazy on current 3D printers that you're likely to have access to without paying tons of money. But the approach was kind of interesting. There's this online lens shop that has M12 lenses, and they also sell these locking rings that are really just M12 nuts, like very thin M12 nuts. And yeah, so this design just leaves room for one of those in the 3D printed adapter. You glue that in place. So we did all that on the last stream, put one of these two lenses in. I got two lenses from there to try out, just by kind of doing my best to pick one based on what I thought I needed. And I got one with a wider field of view. It's rated at 160 degrees, but that's assuming a 1/2.5 inch sensor. I think the sensor in this is smaller than that. I had to make some adjustments in my expectations, but you know, you can use a lens that's designed for a different sensor. It's just that the ratings apply at that sensor size, and so, you know, maybe you'll have parts of the lens that you're not using. Maybe you'll have, you know, like maybe you'll be projecting this image that just only this tiny piece of it actually hits your sensor, and so it's kind of a waste of glass. Maybe you have to take into account that the sharpness rating on the lens is usually specified in megapixels, but that's assuming a particular sensor size. So it's sort of like if you're using a smaller sensor, you're cropping that optical image. Like you're losing those like kind of optical like fake megapixels doing it that way. So even though these lenses are rated to like 5 megapixels, which is more than I needed, I had to take into account that sensor size, even though I'm only looking for like 2 megapixels or so. Anyway, welcome back, folks. And then the last stream ended kind of anticlimactically because I designed a new revision of this, this microscope case, which is what we were really working on. And the microscope case, I sent the wrong G-code file to the printer again and printed the old version instead of the new version, which was kind of embarrassing. So I did start the new version during the stream, but it didn't finish. But I've got 2 copies of that now, so assuming it goes well, we can mod 2 of these microscopes. And then if we need to wait on any prints, I don't know. Well, the other project here is still kind of in the CAD phase. So while I was waiting on that print on the last stream, I made some progress on doing, so like the C920 thing again, the lenses, the lens mount, that didn't require any new design. I just had to buy some lenses and print out this lens mount that someone else helpfully designed. But I want a way to mount the camera in my isopod enclosure and ideally mount it with some ring lights. And actually I think some IR light would be great too, but I might want visible light also and to have a separate controller circuit that can do like day-night cycles. I don't have an IR cut filter, which means there's no filter to move. It also means the colors are not necessarily great, but considering there's not really much IR light coming out of the white LEDs I'm using for the daylight, then it's probably fine for this application. So lens with no IR cut, and then 2 concentric LED rings. I just happen to have these 2 LED rings that would be great for this project. There's a smaller diameter IR ring and this larger diameter white light ring. So while I was waiting for that print yesterday, I was doing some CAD work to make some like bracket piece that would hold all 3 of those circuit boards right where I want them to be. So we can do that assuming the microscope thing works out. So that was the introduction. Let's get back into it. Right. These are some extra microscope or camera parts. This is the original back shell for the microscope that we're replacing. I opened it on the last stream, but I actually ordered a second one of the same kind of microscope because I like them so much, and I wanted one for other stuff like the isopods and one for this desk. And I was thinking about upgrading the microscope and just having a better one for this desk, but actually I like this enough that I just got another one. This goes elsewhere. Got my anti-static wrist strap too. Let's put the C920 aside. It's fairly, you know, I don't have an exposed sensor on it or anything. It's not that delicate right now, I guess. So yeah, this is the new enclosure. Let's get a closer look at it. So yeah, I've got this shiny black PLA, which is a little hard to see details in unless I just totally aim the light at it. And then you see all the detail. So it's actually pretty flat. So yeah, it's got room for circuit board connectors to poke out. It's held together by 1 screw. I'm using only the original screws that came with the microscope, so you don't need any additional vitamins, just the microscope and these 3D prints. The top and bottom hold on mainly through this. There's a long 180-degree ridge that holds this piece into the base. There are also some snaps over here, and up here, and up here. And then this screw goes through here. So it's actually pretty solid, even without the screws in. There's a little bit of creak, but it's pretty good for FDM 3D print. And then I tried to make little icons. They don't come out super sharp in home FDM printing. If you were doing this on a higher res printer, they'd probably be nice and sharp. But here, at least they're kind of legible. There's like a power icon. There's like, I tried to make my own icons for these. The original one did not have these icons. There's like power, settings, menu, like OK/record, and then play. So it doesn't have video recording. It can record stills. But for video, I use an external HDMI recorder. And the newer ones, like the one that I just got, apparently the firmware supports 720p recording over USB, which is really handy. It's not as low latency as the HDMI, so you might not want to use that for soldering. But if you're traveling and you only have a laptop and a little microscope, don't have a separate monitor, or if you want to do recordings at not necessarily the full resolution, then you can just do that with the USB port, which is pretty handy. And I think I mentioned, but these, depending on where you get them, are like $100 to $130 or so for the microscope and the stand. Anyway, this is just a modification that allows you to get it into smaller spaces by taking the circuitry that would normally be up this way and angling it over. So I've got 2 copies of that 3D print. This is the optics and sensor from the microscope. And here's an old version of the print with some problems, but the board is in there, the clicky buttons work, which is very satisfying. The way the clicky buttons work, you might have noticed, but each one is on sort of a little kind of piano key-like hinge that comes out, and so each one is free to move independently. We kind of fussed over the profile here. It had to be weak enough at the bottom that it would hinge really nicely, but not so weak that it would break. And then the thickness of this top part had to be just right so that it would interact with the button plunger the right amount. And then when the top part of the case is installed, that acts as kind of an end stop. So, yeah, let's get the old version out and try the new version. Need the SD card in there. This SD card slot on this microscope is a little gummy, I think, from some of the abuse that I put the microscope through. So yeah, that snaps. One of the problems I fixed between this revision and then what I'm about to assemble is that this snap was just a little bit too tight at the very end. But the others fit pretty nicely. And then this interferes a tiny bit at the edge over here with this shelf as you put the board in. So it does require a little care to get the PCB in and out of the bottom case. That was one of the compromises I made in getting that snap designed. So that actually just have enough room to hold the top piece on, just needed to overlap the circuit board a tiny bit. But with some care you can get it out. Alright, we can bin this old revision. And I've got one that I already assembled. Gosh, focus. Put this one aside for the other microscope. We can just put the board in here. Is this one dry? I washed the glue stick off and left it here to dry. Oh yeah, if I'm actually assembling this for real, I should take care to route the wires, which I didn't previously. Pull off a couple of strings I'm noticing. Yeah, so let's try to do this right. So we have to run the wires on the microscope through the top. And then I'm figuring we probably want to just attach this to the top before doing the rest of the assembly. That should just be careful to photograph all of this properly. Sensor board and this power cable for the ring light. And then I designed this with 8 copies of these pilot holes, so you can actually arrange this on any 45-degree increment that you want. just spin it in there. Not, you know, with the wires connected, but... Hello, hello. Hey there, Dean. Hey there, Nick. Huh. Something interfering in there. I think the wires are maybe slightly in the way. Oh, that's a nice fit. Okay. Yeah, there's a little bit of wire interference, but now it fits perfectly. So I was thinking about the orientation I wanted to assemble mine in. And I can change this a little bit later, but I think I want the front of the microscope kind of facing me this way with the HDMI coming out to the left for starters. Either that or 45 degrees off like that. And the one I'm assembling right now is probably going into the isopod enclosure. This probably isn't the one going onto my lab desk right now. Yeah, I think 45 degree off from horizontal is where I want it. Because I think I'm going to want the mount over here, and then this way the wires can come off, and then I can Velcro tie them onto the mount. But if it goes out the same direction as the mount, I think it'll actually just hit the mount instead. So like, that would be straight out. That's the next hole. Let's put it there. I actually have to do this with the screws ready. Oh yeah, Nick is wondering about the button legends. Yeah, they're, we were just looking at that at the beginning of the stream, but for anybody who missed that, they are very slightly legible, but not extremely. So they could be bigger. I can kind of tell what's going on, but like they're not crisp at all. The left one's supposed to be power, and then like menu, or sorry, settings, then menu, then like record / OK, and then play / display, I guess. I misplaced my bag of tiny screws. Kind of need those for this project. I've got polarizer film in here too. it in here with the plastic parts, but I'm just taking it out. Ah, I put it in with the lenses. Yeah, let's put the screws and the lenses in the same bag. That's a great idea. Oh no, those aren't the same screws. Those are the screws that the lens base came with. That's not what I want to be doing on the stream. Wow, this microscope comes with a really thick user manual. It actually has some features. There's a built-in time-lapse mode. It's kind of cool. Maximum number of pictures, 999. How to get focus? Always an important question. Yeah, I guess the CD it came with includes some capture software. With some slightly microscopy features like grid lines. Alright. Oh gosh, I need those screws. here's the screws from the C920 camera. They're different. Oh, is this it? Yeah, gosh, that's it. I was just stuck right next to the corner of this bin. Cleaned up too quickly last night, and I should have put it in with the microscope body, but I didn't. That was a close call. Whew. So. Gosh, one advantage of wearing these gloves is that I don't have to worry about what part of my nails and or fingerprints are ending up in the shot. Which is actually a significant part of my concern when framing a lot of shots. Not so bad in the live show, partly because you're seeing this low-res preview. I'm picking at my nails, so it wouldn't be good for continuity if the nail polish deteriorates during the course of a short YouTube episode, right? So yeah, a little easier to keep focus plane there. There's the spare enclosure. Better snaps. Alright, so I was looking for those countersink screws that hold these two pieces together. Start with just one screw. I should be wearing an anti-static strap also. I took it off just to look for the things a minute ago. Yeah, the print's pretty good. I'm pretty happy with the mechanical fit overall. Yeah, the labels are a little small to expect them to come out cleanly on my printer, but it was pretty much within what I was expecting. Okay, so I'm finding the orientation I wanted again. So 45 degrees back from, so kind of between left and back. I could add more holes and then, 16 holes instead of 8 holes. Quad core. Okay, and at this point it starts to get a little delicate because I don't really want to put it down and put tons of stress on that one little self-tapper as I'm part-way putting it in. But I want to kind of start to put the other ones in so that they all hold each other as I'm tightening them. This is one of those moments when it would have been a little easier if I put all the different kinds of screws in their own bag. Several different bags of screws to lose. If this does work, I'll get some more footage of me taking the other microscope out and putting it in the same modification. That's why I printed 2 of these cases. Okay. The bag has outlived its usefulness right now. I need more little screw dishes, like things I can put tiny fasteners in where they won't run away. I have a couple here, but I could use more. This part's probably a lot easier to do with the front of the microscope still intact. I trimmed a bunch of plastic off the front, which just has the circuit board exposed there. I imagine with the plastic still there, the microscope is easier to clamp into place. Easier to do that safely. I should do that mod to the other microscope too, though. The working distance is much better if you remove a little bit of the front of the microscope. Oh yeah, the Harbor Freight magnetic screw dishes. I've seen those magnetic dishes. I don't know about the one specifically from Harbor Freight, but yeah, I could use one of those maybe. But it would be cool to have one that's maybe like half size. The ones that I usually see are kind of large for working with like M2 screws. Screwdriver could be better. Let me find a better one. And I was asking what happened with Tuco Flyer. I mean, you're seeing it right there. It's what you're looking at Tuco with. Do you mean at a particular time scale? Because like you'll have to be more specific. A lot of things happen with it. One of the things that's happening with it right now is that I'm using it to show you my cat. It still needs a lot more development work. Like there's still a lot more to do on it, but it's also usable. It's working as it should. I mean, parts of it are working as it should and parts of it are not done yet. And then there are some bugs, like most projects. Like most vague questions, the answer is it's complicated. I'm trying to be very careful with how much I tighten these screws, but they look great so far. Yeah. So that goes in here. Yeah, you can see the full-size view in Tuco Flyer. There's also a debug view, which I don't show you probably as much as I should. It's also what I live stream when I stream it, but I often have this stream turned off these days just because I don't have the remote control working yet, because there's like a ton of software work that needs to happen before I can let all of you drive this thing remotely. And then there's also just, you know, a lot of like personal logistics and like how to set aside like the time and space so that folks can just drive it around when I'm not streaming, because that's also currently not something I really set aside space for. Always takes me too long to remember what channel is which on this switcher. This is the copy of OBS that's running the robot. If I wake up the controller. So the computer vision has that estimate for where Tuco is. You can see it refines that every so often when the computer vision's image tracker actually finds him. But then in between refinements, it's based on rectangle correlation. So as you can see, there's some wobble, and I could have, and I have actually had basically entire episodes on talking about all the different reasons why we're seeing that and all the different possible solutions. So like, it's not something I can solve in the context of like a 10-second snarky question like I get sometimes. But like, yeah, there's a lot going on there and a lot that we can fix. But the usual way I tend to use this is I follow Tuco around a bit, and then he finds a spot to hang out, and then the camera hangs out there with him. And it's actually been doing a great job at that. But there's a lot of work to do in making the more dynamic motion smooth, because right now there's a whole bunch of different problems. Some of it is that it's not very good at smoothly accelerating and decelerating because of actually just some bugs in the motion control that we're still hitting. Some of it just needs tuning. Some of it is that right now I'm actually kind of trying to put the camera significantly below where the actual chords intersect in order to give it more reach into the space in that vertical axis, which is, you know, a direct trade-off against stability. So like right now I have actually got this set up with an emphasis on like reaching down into the space rather than trying to keep the wobble minimized. But I know a lot of people think the wobble's annoying when they're seeing it in the moment, so yeah, I'm aware of all of this. The software stuff to work on kind of comes in a lot of different forms. There's just like kind of polishing up what's there a little bit. But the major areas that need software work are in supporting the onboard sensors and in just like some coordinate system stuff and other infrastructure so that I can represent like input commands relative to the camera rather than relative to the, you know, the global coordinate system of the robot, that kind of thing. So yeah. Aw, digital radio hacker fell asleep on their keyboard. But they're wondering if the print worked out. Yeah, the print worked out fine. In fact, I did a second one. I just hit print again intentionally this time. And I've got 2 copies of the latest design that both printed great. So that's what we're working on right now. Let's make that full screen again. The lightweight AWS infrastructure is a little bit slower at damping, but it does get there. So, yeah, I like this. It's basically a flat piece, but there's some subtle features here. There's a little cutout here to keep the screw head kind of recessed very slightly, mostly for aesthetics. It's not as necessary for functional reasons. And then these edges are angled a little bit so that they interface with the snaps on the other half. Yeah, and that screws in nice and sturdy. So next, let's just plug this in. And because we've got to plug this in anyway, this is a good chance just to test it and see if the orientation is actually as we expect and that nothing else is wrong. Make sure that the ring light is actually still working, because the wires for the ring light within the optics assembly are quite delicate, and every time I mess with that, I feel like I might break the ring light. That's right, I'm in manual focus, so I've got to keep the focus plane in mind. I don't actually remember which side of this flat flex connector the pins are on. Looks like the top. That's also another reason to test it, right? Okay, so that should be ready to go. Good cat. Okay, this is my other microscope, the one that I have not modified yet. So I'm just going to take the cables out of that and plug it into the current victim here. Mini HDMI, mini USB, ring lights on. Do we have picture? Did I plug the sensor in upside down? The ring light brightness control works. The blue LED on here is on. I forgot we had to worry about that. Maybe I plugged the sensor in upside down. Let's try swapping that. It's not bad, you know, it's not got connectors on both sides, but it's just not connected effectively if I have it upside down. You see these flat flex assemblies with pins on one side or on the other side, and I wasn't sure which one this one was. Might have guessed wrong just now. I guess I should be getting this footage. So yeah, just trying to put it back in this way instead. I don't know about that. Can we get a closer look? Does it look like the pin's on the top? I think we had it right the first time. I think it might have just not been seated all the way. That feels right. Let's just try that again. Yeah, same results. Well, I guess I'll try flipping it. Just didn't look like that would have been right. And there are a number of ways we could see which orientation is right. There's just, you know, if there's any harm to come from powering this thing up without the sensor attached, we've already done that, and it's not like we're attaching it incorrectly, it's just effectively not wired. That kind of looks right too, it's just, yeah, hard to tell. Blue LED again, black screen. Oh, there it is. Yeah, it was upside down. There's the focal plane. Zoom out a bit here. Cool, that's my microscope. Let's put this case together. Okay, so now I need to use more of those self-tapping screws to attach the circuit board to the bottom half of the case. And then I need to put this all together while carefully routing the wires somehow. And then this requires a slight sputtering of this snap to get the case in. Cool, and then it's a great fit. I'm not sure whether to classify that as a defect. I mean, I designed it with that in mind. The reason was to make that snap strong enough, but we could try to compromise more. Button feels good. This is fine. Everything's lined up. This takes 4 of the longer self-taps. Oh, tinier. Requires a pointier screwdriver. I'm really happy that this right off the printer works with the original hardware. It's my favorite part of this design so far. I haven't done any cleanup. I mean, there were maybe a couple of little tiny strings that I picked off with my fingers, but that was just aesthetic. No mechanical cleanup, really. Cool. Don't want to over-tighten those, but just barely snug. Alright, I think now the deal is just to insert the top half and close it up. So keeping the wires out of the joints. Might be easier said than done actually, because this might rub against the wires. The knob. Did my camera just crash? It usually stops after like 20 minutes, but it's not restarting. Oh, now it's gone. It was a little bit hung there. Interesting. Is it having trouble with this SD card? I think we switch SD cards for good luck here. Oh, Danielle's wondering how I took the exact coordinates of the PCB holes. Yeah, that was a lot of work. The thing that I ended up doing was basically calipers, but there were very few flat references on the board. So I got some of the numbers I needed by measuring the original case, because there were some internal flat supports there. Ooh, this is an old SD card. I should really take some of these out of service. I hope that video is all good. This is a newer card. this on my keyboard. That's not going to end well. Yeah, I mean, getting the coordinates for the PCD, that's like one of the hardest parts of the project. Like it's if that's what you're having trouble with, like that's pretty normal. Um, and I would definitely recommend, you know, kind of an iterative approach if you can, where you do your best to get the numbers and then print or otherwise manufacture using whatever is easy to you, either 3D printer or like cardboard or paper or laser cut metal, you know, whatever you have at your disposal. Just make something that you can use to test your dimensions and see how accurate they are. I think I might need to take care to kind of squish the wires into this compartment behind the sensor so that they don't rub on the brightness control. So like that maybe? Some kind of plastic rub shield for the brightness control might be a nice addition. Thinking about how to do that. This one might need a slight sputtering in still. Yeah. Gosh, I can see why so many people on YouTube wear gloves. It is a lot easier to photograph stuff you're handling without having to worry so much about your fingers. Feel it rubbing on anything. Doesn't mean it isn't, but it's probably alright. I don't expect to be adjusting that a ton anyway. Okay, the snaps all feel great, and that's honestly holding the case together enough that this screw is not extremely necessary, but let's put it in anyway. That seems kind of great, actually. Let's try it out. Ring light comes on. Takes a second to boot normally. There it is. And then push the usual button to turn that off. Oh, that's great. I mean, it's not focused right now, obviously. Well, worry about fingerprints in multiple ways, as in like exposing, worry about fingers as in fingerprints, yeah, also just like how my fingers look, are they in focus, like how are they framed, you know, it's like, it changes the photography equation somewhat. This is great. I don't think I worry about fingerprint exposure as much as some people because it seems pretty inevitable. But, I mean, yeah, that's something a lot of people are worried about. Oh, oh, I like that. That's what I was going for, and you can kind of adjust that to get the connectors completely out of the way. And then this would really go well with a Velcro strap. Here's one. So, then imagine there's a clamp here to actually hold the whole thing. That's what we're going for. Just notice how much more space I have here. I could even clamp this a little further down the body of the microscope, probably. Not quite as stable. It's designed to clamp further toward the top, but yeah. That's my low-profile microscope mount, basically doing what it's supposed to. On-off switch works. I don't use a lot of the features of the scope. I just tend to turn it on and then do everything else in software. But I want the buttons to work, I guess. That's the menu. You can kind of see it in the back there. But yeah, that's the one that I'll be setting up with the isopods shortly. So I'm pretty happy with this. I think I'm going to post it on Thingiverse and Umagine. But right now, let's go ahead and mod a second microscope with the same thing. Put it in the other case. This cable angle is still slightly awkward. This is kind of a thick HDMI cable, and so I kind of still worry about the stress on the board there. But yeah, you can fuss with the cables a bit. Also, this is really set up for my desk. Like, this covering is what I use to keep my cat from chewing on it, but in the isopod enclosure I have different concerns. So yeah. I can see why they wouldn't do it this way as their original product design, because I imagine this is harder to ship and store and everything, but then again, that was my theory, and then I ordered a second one of these, and the box it comes in is so big that I don't know if it's really saving them that much. Maybe people just expect microscopes to be long tubes, and something like this doesn't look microscopy enough for their customers or something. But I like it. Yeah, let's make another. Yeah, this is pretty good. So I haven't quite gotten to this part, but for a prototype, I was just grabbing this with some vice grip pliers and just sticking this up through the holes that I've already got cut in the isopod enclosure, and then grabbing that with vice grips. I can still do that, and that'll be fine for temporary sake, for testing it. But I think what I actually want to do is build like a flange adapter, something that clamps onto this pole with a set screw maybe. And then I think what I want to do is come up with a standard bolt pattern for isopod accessories, and then drill a little grid of bolt holes in the top of the lid, reinforce that with something, and then I'm actually thinking about using the what are they, like 3/4 inch? I think they're just 1/2 inch by 1/4 bolts, the ones that Tuco likes to chew on. I think I just might use some of those as fasteners because I'm joining plastic to plastic, and that's about the right size. Yeah. Joseph expects to see clones of this design from Shenzhen within the week. Well, if they're gonna make some, I'd be happy to point people at them because I don't necessarily want to go into manufacturing on microscope cases right now. I'm happy to just put this design up on Thingiverse for other people to print right now. I don't know. I mean, if y'all like this design that much, maybe I should open a microscope accessory shop. All right, let's get out the other one here. This is the unmodified microscope. Got this scale nearby now, which should be handy. Oh, this mod leaves you with 2 extra screws. I should put those with the original enclosure, I guess. Those are the screws that hold these corners of the enclosure together, just around the connectors. Which is kind of a good idea. Like, if you're expecting a lot of stress around the connectors, that can help relieve the circuit board a bit. Yeah, we should just keep the extra parts from both these microscopes together at this point. Oh, somebody doesn't know about the isopods. Oh yeah, the isopods. So the isopods are great. Let's use a computer with a little bit more spare CPU than this one. It's okay, I'm always happy to have an excuse to look at the isopods. Oh yeah, this is for later. Keep that open. So if you go to live.diode.zone, there's an isopod site. Oh, cool. Glad someone else is having good luck with the streaming hardware. So yeah, these are the isopods. They're not doing a lot right now, but... So I actually have some fresh off the encoder, delicious time-lapse footage, which needs a little bit of editing before I can post it. So I'm going to edit it and throw that on Diode Zone and maybe YouTube pretty soon. But yeah, if the isopods are being a little quiet right now, I can show you some time-lapse footage that I think I can get to on the network from here. There's a read-only share of... Oh wait, this isn't where the... This is where the raw footage is, not the time-lapse footage. This is still useful, but... I was posting on Twitter about my 107 gigabytes of isopod footage. That's this file. So yeah, these are my little bugs. They're cute. So yeah, isopods are actually a pretty broad designation of creature. There are many genuses and like 10,000 total species of isopods. These are related to the little like pill bugs or wood lice or roly-polies or whatever you want to call them that most people see outside under rotting logs. So I've got these as pets. They're in the closet next to the 3D printers, and I've been trying to stream them 24/7. So yeah, if you go to live.diode.zone/isopod, which also there's a redirect from isopod. If you go there, then there's a live stream. Right now, they're not doing a lot right now. But, you know, they do things. The camera is actually on just a pretty small part of the enclosure right now. The C920 I'm putting the fisheye lens on should give us a better view of the whole thing. But right now, I've got a camcorder in there with a zoom lens. And isopods, yeah, right, they're great. So, and the time-lapse is actually kind of interesting too, because it's not just the isopods moving around, but like the leaves move around. And not just because the isopods poke them, but also because like they dry out and curl, and it's pretty weird. Also, this leaf has some fungus on it that we might see some interesting stuff in the time lapse from. You can kind of see this black spot on the leaf changing size, which I think is related to moisture. I got some time-lapse videos of leaves drying out, which was kind of cool. I was doing like a control time-lapse to see if I had any mites in my new enclosure, because I saw them on the previous one. And no mites as far as I can tell, just leaves drying out, which was satisfying. I think I can get to this share. Yes, this is where good stuff is. All the time lapses. Ha ha ha. I've got a script on one of my servers here that just, every time it sees a video in one of several directories, it automatically does time lapses at many different speeds so that it helps me sort through footage. I mention this occasionally, but I sometimes get questions about my infrastructure here, and I try to keep everything I can in this repo called broadcasting on my GitHub. So this is sorted by computer, and then it has config files and scripts for each of those computers, and there's an overview in this README. But yeah, this talks about the hardware I'm using. It's still fairly accurate. This needs like maybe a tiny bit of tweaking, but it's still pretty much what I'm doing. So yeah, this is the machine that does all the encoding, and it's running the Tuco Flyer. So it's just like running flat out most of the time that I'm streaming. When I'm not streaming, it mostly just does shop audio stuff. Yeah, that's the transcode server. But yeah, if you go in here to the transcode server and then lapser, this autolapse.py is the script that generates all the stuff over here. So we got some new ones. So this is 4096x, like 12 powers of 2. So I need to edit out these sections where the camera froze for a long time. I've been having these intermittent problems with the video grabber card. This setup, I don't have this on the broadcasting setup. I should really add a section for the isopods, because this is on its own dedicated machine running OBS now. And what you're seeing is being captured on this HDMI USB 3 video grabber. I think that video grabber might have some like flaky power supply in it or something. So once we get some other camera working that I can substitute in there, because like I can't be working on all the cameras all the time, then I can take that camera out and we can debug it a little. Or not the camera, the grabber. The camera's been fine, but the grabber is having problems, and I need that for the microscope. Well, I guess I don't 100% need it if I used one of the microscopes that has 720p USB output, but I would like to use it for the microscope. So yeah, and so that was 4096x for a couple of days, I think. But if you look at it at a somewhat lower zoom, then you see a bit more of the isopods' behavior and them walking around, and less just kind of their hangout spots and what the leaves are doing. So yeah, I want to edit a few of these together, make a little interesting clip. It would be interesting to add sound to this. I know if I was on one of those shiny AAA YouTube channels with a million subscribers or whatever, I would just hire a Foley artist, and you would hear all these like weird crunching, squishing noises as the isopods eat that have nothing to do with what they actually sound like. And then people would love it, and you'd get like hundreds of thousands of likes, whatever. But I don't know, like it seems more appealing to me to sonify the data that they're actually producing somehow. I love the idea of contact mics, and we did a little bit of experimenting with that, but I need a better preamplifier setup before the contact mics are going to be useful. So right now I don't have any audio capture, but I have these time lapses, and I wonder if there's something I could do with the full res video to get some extracted audio into the time lapse. So Danielle's wondering if I switch off their light. Right now they just have like really dim light all the time. I want to make a thing, like some way of like switching them between different kinds of light sources for like a daily cycle. But right now they just have like dim light, and they don't seem to mind, but it, Yeah, it seems like something else would be better. Isopods are not very light sensitive. They're really sensitive to moisture and temperature to some extent. And they like the dark because they tend to find like moist locations where they're not going to be bothered. But I was like reading some research about this, trying to find out whether isopods care so much about light levels and what kinds of wavelengths they care about and like what kind of light sources they would thrive under and whatever. And mostly the researchers were just finding there wasn't that much of a correlation. So, you know, I'd maybe want to have more options, because right now there's just like a tiny little LED lamp kind of pointed at the wall nearby, so it kind of diffusely illuminates the leaves. But yeah, I want to experiment with different light sources, try to find something that they like the best. We also found out that this C920 replacement lens that I was setting up already doesn't have an IR filter, so we were going to add some IR illumination. Yeah, those are the isopods. Try to post an edit of that soon. Oh, that's funny. In reference to the microscope equals long tube association I was postulating about earlier, Digital Radio Hacker has this mobile phone they bought, which is built into the case of a car stereo to make it look like a mobile radio. It's funny. And then they've incorporated some lumps of steel to make it seem heavier so that it seems more like legit or quality or something. Yeah, the last time I encountered such a sketchy sort of completely counterfeit enclosure design, it was a Bluetooth adapter I got really cheap somewhere. I was looking for like really cheap Bluetooth adapters, and these claimed to have a long-range antenna, but the antenna was completely fake. It was just a lump of plastic, and the circuit board had just a regular antenna on it. Yeah, no, that's my plan, that I'm probably going to have like a day-night cycle, and then for night I'll be using infrared light. I've been kind of curious like what their sleep schedule ends up looking like at the moment, because I mean they do sleep. They sleep and they're more active usually at night, but like right now the most variation they're seeing is probably in temperature, because even though I have them in like a thermostatically controlled environment, the thermostat kind of has trouble keeping up at night sometimes, and then during the day it's probably on average a little warmer. So yeah, but yeah, IR light is definitely the plan. And I mean, I was trying to look for research on like, well, do they care about IR light? Do they care about visible light? You know, what wavelengths do they? But yeah, I couldn't find much. So if you know more about like what kinds of lights they're likely to like, let me know. But I found some old research where it was kind of like before modern LED light sources were available, and so they were using big tungsten lights with filters, and it seemed like they were having more of an effect of like drying out the enclosures faster because of that, and not so much that they were measuring the actual light wavelength effects. So yeah. Yeah, I like the way Nick is thinking that I could use a shiny sticker on a leaf and then an optical microphone, like a laser bounce kind of thing, to get leaf noises. Yeah, that could be good too, because I do like the idea of not having to put wires down into the dirt, because they, you know, it's just like harder to keep them like clean and harder to not bother the isopods when I'm taking the lid off that way. If everything can be on the lid, that's good. I probably will have some temperature sensors though. I could do all the temperature sensing non-contact, but then even if I was willing to spend, you know, an arbitrary amount of money on non-contact temperature sensors, I guess they're not that expensive nowadays. You can get breakouts that are like under 20 bucks, I think. But still, I would only get the tops of the leaves, and it'd be nice to know other temperatures. So I've got some of those waterproof DS18B20s that we could use for that. But yeah, I definitely want to get some sounds, especially for the time lapses. That would be great. And yeah, getting the like munching on the leaves, that would be great. If I could actually get the vibrations on the surface of the leaf. Like imagine if you had a microphone and you just had your ear down to the leaf or something. Like that's the effect I would love to have. And Nell's asking about contact mics. Yeah, no, totally. We're on the same page there. I tried a really basic contact mic setup just with some stuff I had handy, but it was fine on the desk here, but then I bring it in there and it's like all USB noise all the time. So I just need to build a better preamp and shield the mics better. But yeah, contact mics, definitely something I want to try more of. Okay, so actually let's take out the extra screws first. These screws here, you can just put aside if you're using my mod. Yeah, I bet the sound is interesting. I don't really know what to expect, but then I was also thinking maybe there's a way of sonifying, like, imagine you are recording a waveform of all the motion vectors. So maybe you do optical flow analysis, maybe you take this out of the H.264 stream. Although H.264 motion vectors are usually a little too, you know, they're like compromising a lot. They're not necessarily going to give you the best optical flow data. But do some kind of optical flow on the pre-time-lapse video to get a waveform which, once you do the time-lapse, will be magnified up into audio frequencies. That seems maybe like a thing we could do. And that would just be all software. Like there's probably some algorithm you could run on that 100 gigabyte video file that gives you some interesting audio. Oh yeah, and then lots of people have mentioned the video audio recovery stuff that, yeah, like I guess that was an MIT paper years ago. Yeah, it'd be interesting to try that too. That might work. I mean, that might even just be downright easy if I was talking about kind of working on a video pre-time lapse. I don't know. I would probably need to do that in an OBS plugin though, because I imagine the H.264 compression would do a disservice to the audio quality there. Danielle's wondering if I'm watching Wintergatan. Not super regularly. I've seen their stuff. I haven't been like super regularly following a whole lot of stuff, but yeah, I'm familiar with some of the stuff they do. I mean, I've done stuff with contact mics, but like I know that they're doing some flashy stuff with contact mics. So like I was just saying, you can use the H.264 motion vectors, but it's a fairly low quality form of optical flow, and you don't need machine learning to get motion vectors. Like that's called optical flow. That's like not every algorithm is machine learning, kids. and like it's the same algorithm that you're seeing inside of a video compression tool like an H.264 codec. It's just that when you're doing that in the context of video compression, there are a lot of compromises that you make in order to keep the compression speeds up. And so you're not necessarily looking for the optimal optical flow during video compression. You're looking for the solution to a problem, which is how do you represent this video sequence using this particular model of decoder? Like what bits would you give this decoder to most accurately represent this input you have, which is a slightly different problem. But if you look at OpenCV, like they have optical flow algorithms you can use there that are great starting points. Some of them are even GPU accelerated. Oh, this one uses a regular flat flex. I was wondering why the other camera used that strange cable. It seemed like they could have used a flat flex, and this one does. Okay, cool. Let's take this screw out too. But yeah, as far as like how you would get the motion vectors out of H.264, I know I've come across projects to do that, but I don't remember any off the top of my head. Okay, I think the other case had a little bit of glue too, and this one doesn't seem to have any glue, which is handy. Try to get that screw out. Whoa, long wire. Why is it so long? Same circuit board it looks like, same lasered off part number. Long wire. Same screw holes. Oh gosh. I'm always like attentive to noises, and noises I don't recognize kind of throw me for a loop. And so every time the UPS goes into self-test, I get a little minor panic. I don't know if anybody else noticed that. There are 3 large UPSs on the side of the room. So we looked at this board a little more on some of the earlier streams in this project. It's some kind of system on chip with its label lasered off. I'm guessing it's the kind of chip you would find in like either a digital camera or a cell phone, but it could be a lot of different things. There's not a lot of indication about like what operating system it runs or what kind of chip it is, unless you were to either find an exact match for the pinout, which would require destructive disassembly probably, or the easiest part is to just look at the firmware. So pull it off that flash chip there. Okay. That just comes right out. Oh, that's pretty long too. Nice. Such longness. Look at all that longness they gave us. Same on that side too. Then we get a screw, and then case parts. So now we can put aside the case parts. We have these 3 pieces of plastic, which we no longer need. This is a Twitch chat question from earlier. Somebody was wondering, WTF is that? And I'm curious if your question's been answered right now. It's an enclosure for a microscope, but I don't know. Who knows if you're still here? Twitch is a great place to post comments about things that you could find out by just kind of hanging out for a while, I guess. Okay, let's take these connectors off both. I hope we left enough opening. I think we did. The opening I left is pretty wide. Alright. So important to note, the pins are on the bottom. The blue insulation tape goes on the top. The silvery looking plated pins go on the bottom. That will be important later. That seems pretty much the same. I think that's the same date too. The other board I think was also November 2014. I think the other one was maybe 1.0 though. I'd have to check the video to be sure, but this might be a slightly newer version. So again, these are 2 instances of the same general type of microscope, sold by different brands, I think, but it's the same design. So the design seems to be called UM016. And then you can find it under different brands, but it's often sold as kind of a generic 1080p microscope. So, all right, now let's put this into this case that we designed and 3D printed. I've also got an extra copy of the first couple of layers. I thought might be interesting on camera for some reason, but I think I'm just going to throw that out. All right, so these, I just assembled these temporarily to test the fit, so I'm going to need to slightly disassemble them. Use a little spudger for that. Spudge these slightly. Get some spudge on. Spudgy. Just like taking apart something someone else designed. So snaps over here, here, and here, and then a ridge over here. That holds it on pretty tightly, but then there's also a screw for some added insurance. And vents that you can only see through at a particular angle, just to keep the light from hitting the sensors easily. And some, some imperfections on the bottom, but you can also sort of make out the icons I added, which would look better on a higher resolution printer. And then these kind of little like hingy areas where I've got these fingers that each move separately for each button. And just try to tune that so that it's strong enough but also moves the right amount. And I think that's basically it. So then the assembly process involves putting this through here, screwing these two together at whatever angle you want. There are 8 screw holes here and 4 screw holes here, so you can actually put in 4 screws at any 45-degree multiple. I think I'm going to assemble these both the same way though. Like, that's kind of my preferred angle for these microscopes, but other people might have different preferences. Oh yeah, also looking at how this cable is routed. So those very thin wires are enamel wires that run power from the LED ring light on the front of the microscope back to this board, where it just attaches to this lead and then to the main board. On the other optics assembly, I had fussed with these wires a little bit, like trying to take it apart, so they were not representative of how it usually is during manufacture, but I just wanted to look at these here. So it looks like they come straight out along the tube, have some space to bend over, and then they loop down and solder onto the board. So these wires just go along the edge of the optics tube, and then you'll see them, might be a little hard here. Yeah, they solder right behind there on that ring light assembly. So, snake those through. Yeah, and then this fits flat on there. Not super snug, but you can get the screws in there. I like that fit. It's very good. So then, same as before, zoom facing us, and then it could go straight out to the left, but I think I would actually prefer to angle it 45 degrees over, and it would be that set of holes. And then these are the 4 countersunk screws that came with the original microscope. I'm just going to try to put them in just a little bit before tightening them a lot. So, I mean, I could have taken that off the board if I needed to, but I don't need to. I'm just going to leave that assembled. I do want to take this off. There are many ways to do that. I think before I just grabbed that in the vise and pulled it off. I just saw the comments over there. Wow, such length, many distance. Yeah. You know the way to my heart through Doge memes. I think I was a lot less depressed when I found it easier to relate to like internet fans in general, and I felt less like I couldn't trust anybody. It's nice to find a middle ground there. Oh, feels like this is not the right screwdriver. I think I just need this slightly larger. I still don't understand Phillips head screwdriver sizes, really. Like, is it just me, or are there a lot of different standards and none of them make sense? Maybe there's just a standard that makes sense somewhere that I haven't read. It's a little hard to push on these enough to help them thread without slipping, but they seem to hold nicely. I can replace the PLA easily, but if I mangle the screws a little bit, that's harder. Okay. Those seem like they're all in enough without being over tight. Okay. So then we've got the flat flex and the power wire. Can we go ahead and take this off? There's an alignment feature over on this side, but then I think it's just glued in. Let's use the vise of shortening. Don't want to damage the ring light, right? So that snapped it all the way down on two sides. I think I can get it out the rest of the way by hand. Yeah, great. The front of the microscope actually looks pretty great without that. It's just a nice flat matte black surface. And on the other microscope, I kind of trimmed this plastic back slightly, but you don't have to do that. This is fine with just that part removed. Alright, so also don't need this. This can go with the extra parts. It's slightly damaged, tempting to throw it away, but it's not completely damaged, I guess. Can save that. It also might help if I need to design some accessory that fits into the front of the microscope. That gives me something that might be a good feature to use to align it. Okay, so now I need to reattach the circuit boards. This cable is so long. It's just like way longer than it needs to be. That must just be what they had in stock. Or maybe it makes it easier to assemble somehow by having it this long. It's like one of these little 2-pin JST style. Clicks in there. And then, like we were saying on the top part, this will fit either way, but only one orientation will actually connect it to anything. So we want the blue tab up and the pins down. Covering a couple of interesting test points there. I still cannot fathom why the other microscope used a round cable for this instead of a flat cable. It looked really expensive relative to this. Must have just been something they had handy, or something they used for prototyping, or for some other kind of case maybe. Cool. Let's test it now before going further. Plug in the HDMI and the USB. Cool. The ring lights have kind of a weird hue on this LED, or on this flashlight. They're almost like very slightly greenish if it isn't me. They're mostly warm white though. Okay, let's put it the rest of the way together. Okay. So then just trying to keep these wires out of the way. Oh man, this will be much easier to keep out of the way, I think. Because the flat cable will want to... So I might crease it over here. You can see I'm putting this kind of hard bend on it, which wants to... It wants to bend the rigid portion of the cable next to where the connector is. So I think I'd be better off like creasing it very slightly right there to help it stay bent. So I just apply a little pressure there to gently crease the connector, or crease the flat cable parallel. Not too much, just gentle, like that one. And then I want to take this wire and let it run under here, keeping it kind of out of the way of all the posts, especially that one. I could actually go around that post. I don't think that's a good idea. I think I want to keep out of the way of everything. That could even go... That could even stay above all of this and kind of, I don't know, sit right there next to the RAM. Servo AF. Right, and then as I was saying before, there's a little spot where there's some interference. Oh wait, maybe there isn't. I think they might have changed that. No? Yeah, okay, it's between this edge and that edge. So the way I usually resolve that is to put this edge in first, and then just spudger this edge very slightly. Just that much. Does it fit? Oh, slightly more than that. That got it onto the shelf, not past the shelf. Oh yeah, good, same fit. I don't think they changed the outline at all. That seems to work too. All of that seems to work. Cool. And it looks like to put this together, this is the orientation we're working with on the flat cable. So it's a little weird, but I think we can do it. It'll look kind of like that as it goes together. So next step is 4 self-tap screws on the PCB. I can't remember the last time I did a mod like this that just replaced the enclosure on a normal like consumer product, but then otherwise kept it pretty much the same. It's pretty satisfying. Like, I'm kind of doing these projects in the wrong order because this microscope also requires the HDMI grabber for the isopods, which is what I'm having trouble with. So I still need to fix the HDMI grabber, and I can't really do that until I have a different camera in there that can be the primary camera. So I still have to get the C920 kind of further encased before I can do a ton with this. But I figured this would take a bunch of design iterations, and it would be nice to do the simpler project while we were waiting on stuff for this, and that seemed to kind of work. And again, very careful not to over-tighten these. That original crease in the cable actually isn't really helping. It might cause the flat cable to want to rub against the potentiometer at some point. Spudger helps with the snap. I don't know if you can see what I'm doing there. I'm using the spudger to push the snap very slightly outward while I'm pushing the case on just to get it in there. Just help it out a little bit. All the buttons work. Oh, that is definitely rubbing the flat cable though. Can I use something thin to push it out of the way, maybe? I made that too tight, like that. I mean, it feels great, but it also means there's no room for a tool to go in there. I can go in above the SD card. I mean, that's not a super bad problem. If you were to adjust this a ton, it'll gradually wear a little groove in the side of that flat cable, which might eventually be a problem. Just looking for a way to fix it. Maybe we can Kapton tape something down. As for opening it, oh yeah. Twisting a spudger in the micro SD slot actually seems to be a good way to open it. For some values of good, I guess. Would have been a better design if they kept these parts. I mean, they were not planning on the cable coming out this direction. I really can't blame this on anybody else. Can I fold this up behind the sensor, maybe? just imagining if there's another way I could solve this problem. I can't have any features on the top case recede down toward the board because that's already the printer bed. And I can't go up. So really this would require a separate piece of, like a separate 3D printed piece just to serve this purpose if I was going to fix it in the print. Maybe I could put more of this cable behind the board? I don't think that's going to do a good thing though. Maybe I can tape it to the underside of the top like that. Double-sided tape, maybe? It's out of the way right now, and the tape might help it stay out of the way. Oh, focus. Okay, and then getting them together just requires seating that snap in, and then doing the rest. Oh, that's even worse. What? Oh, that might be a different problem, actually. That might be interference in the fit. I don't think that's actually fitting quite right. Oh, no, I think it is maybe the first problem. Damn. Yeah, okay. I do need to... Move that cable slightly. I might just need some more clearance above the whole board, really. Like, I could make this whole thing a little thicker and just leave more room for the wires. That actually kind of feels, I don't know, it's hard to tell. It's really hard to turn now, like something is just flat on top. Something else could be going on. Oh gosh, I put the tool in a little too far and torqued the SD card slot itself, which is not what I wanted. There's one hazard to doing it that way. Definitely do not spudger the SD socket itself. that still work? Yeah, it feels alright. Gosh, maybe the design could use another revision. Just make the whole thing a little taller, maybe also a little more clearance around the SD card slot. Because what we're seeing right now is really just like variations between like one version of this camera and a different version of the camera. So we're making the design a little more broadly applicable if we make it work well with both of these. Oh gosh, all the neighbors are making noise now. Whatever. I'm not extremely bothered if I break the SD card slot, which I think I might have just contributed to. Well... I mean, I could tape this down at a particular angle, just try to get that just right. I can't even tell if that was the problem we were just hitting or if that was a different problem. So right there it still moves freely. Right there it still moves freely. I might have also just done a bad job at assembling that snap just now. Oh, now it's too tight. Is there debris? Oh, it's the tape. Some of the tape is rubbing against the knob and doing its job, being tape, you know. Okay, I think we're converging on good strategy here. I don't think we have to make the case bigger. It might make it easier to assemble, though. So what if I just attach this there-ish, just to keep it out of the way of the potentiometer? Not on the top case, on the bottom case, and then the top case floats. And we could do that with hot glue, with cold glue. I'm actually thinking 3M VHB tape or equivalent would be good for this. So I'm going to grab a little bit of that. Oh, I feel like I was using that roll recently and didn't put it back in the right spot. Got other stuff that'll work though. What about these? Yeah, This stuff isn't as good, but it's just some other kind of foam tape. Trying to avoid using my scissors to cut this, but I don't really have a good cutting surface, and everything I use will stick to this tape. I do have non-stick scissors, though. Non-stick. Kinda. Much better than most scissors, though. Okay, I'm just going to stick this over here, kind of behind the buttons. Hopefully this stuff is very non-conductive. Okay, so that's not going to interfere with this. It's very far out of the way now. It looks like the wire for the ring light is in a fine place. It's got tons of space on the underside of the enclosure to hang out, and it's kind of snaking its way around the edge of the board there. Okay, that's in the groove. Snark. Cool. Didn't need a spudget that time. It feels like the top of this is interfering with the lid very slightly. I'm not really worried about it though. We could add a little more clearance and it might be better, but it's not going to break any wiring. It's just going to rub two plastic pieces against each other and add a tiny bit of friction. So whatever, that seems fine. Card slot's fine, although I won't really use it. Buttons feel fine. Great, this just needs a screw. Also very careful not to over tighten any of these. They're a little delicate as far as screws go because it self-tappers into PLA. But yeah, feels pretty strong. Not used to the brightness being up here now. So that's the brightness knob. Feels fine. There's the power switch. Just turned it off. Oh, it has soft power for the LED. I hadn't noticed that. That's our friend. 8GB card. Can you see the data? Cool. I think that's basically it. I'm gonna put it on Thingiverse, I guess. And you imagine it's already on GitHub. And you get a few more shots of this being used. See, part of why I like this is that the cables point toward where they need to go, and part of why I like it is that it doesn't block my view of the screen. The reason I made this case mostly was for the isopod enclosure, because there it just doesn't really fit in its original form. I have to have it poke out the top of the box. So you could put a box lid here and it would now work, but this also keeps it out of my line of sight to the monitor. And you can assemble this with different angles between the top and the bottom. This is just what I chose now. Changing the angle requires taking 4 screws out and putting them back in. Haven't looked at the CD yet. The user's manual claims that this has some capture software. Oh, are those tracks or something else? I don't know what those concentric lines are you're seeing. Those are visible to the naked eye as well. They're way too big to be data tracks, so there's some other effect we're seeing. Yeah, well, that seems successful. Let's maybe do a little more work on the C920 thing, since that's also in front of us. But that marks the end of this little mini project. I don't usually do the wrap-up voiceover or whatever on the live streams. I usually record those later during editing, because I tend to need some time to figure out what to actually, how to actually turn a thing into an edited story. I probably worry too much about that though. I haven't really tried using the SD card on this camera, because this one has newer firmware than the other one. Gloves. I think I did damage the SD card slot on this one actually. It still kind of works, but it's not great. So it sees the card. I could take a photo. Yeah, that's, I think, a photo. Yeah. It seems like the software package you would find on a digital camera, right? And there's live view again. Yeah, alright. Oh yeah, something to look at with the microscope. I got this USB card in the mail soon, or recently, and I want to use this for my iPod streaming PC, probably. But let's take a look at it. Oh, interesting. Thomas says they have a dash cam with almost the same interface. Yeah, there's probably just like whatever company makes that system on chip probably has like a development kit for it. Either that or there's just basically like a reference design out there that everyone copies. So, this is a weird device that I found online that I was looking for cards that might have you know, multiple independent host controllers so I could just load a machine with webcams without all the webcams using up the isochronous bandwidth on their respective USB bus. So this one's interesting. It actually has a separate USB 3 controller for each port of these 4 ports. And then I think that's a PCI bridge. But I want to take a look at this. This is going inside of one of my computers soon, but wanted to take an opportunity to look at it on the stream first. Maybe we should go back to servo AF. Oh, these tiny microscopes. Okay, yes, it's a tiny microscope now. It's not just a regular microscope. Gotta use your dull X-Acto blades for something, right? I would be surprised if the system on chips you see in dash cams are used only in dash cams. They're almost certainly designed for like a wider digital camera or portable device market of some kind. But the firmware might be kind of focused on a particular digital camera segment, and then it gets customizations for like dash cams or security cameras or whatever. Cool, it comes with this little bracket. Part of why I got this one is I have a couple of cases that are low profile and need something that fits there. So that'll be useful. Drivers I don't need because I'm running Linux and I'm sure whatever on here isn't helpful. Turn it off, put it in. Yeah, thanks. Oh yeah, that's a good question. Maybe we can go into there too. Larry is wondering how I designed the clips that hold the lid in without screws. Yeah, I can show you that really quick while we're still on this topic. Go back to the machine. Alright, so this is Autodesk Fusion 360. This is the file for the UM16 mount. You can also find this on GitHub. Yeah, UM016 microscope ring right angle under scanlime. And this is going to be microscope right angle mount.step or .f3d. So yeah, the snaps, those are easiest to see in section view. I do have a screw hole there. It's just you can't really rely on the screws on their own without the case feeling kind of creaky and like it's not really put together that well. In fact, the main problem I was trying to resolve here is before adding the snaps, when it was just the screw here, then you could press on the case over here, and this top of the case would actually flex in and out relative to the bottom half, and they would scrape, and the scraping would actually cause the edges to interlock according to their 3D printer layer lines. And then that interlocking felt a lot like a tactile switch. So it's like kind of clicky in this way that wasn't actually helpful. So that was what it kind of started me down trying to add snaps to eliminate that. So here's what I'm doing. Oops. Yeah. So if I move the mouse at all, it like hides the outlines. So the green section there is the top lid, the blue section is the bottom lid. The idea there is that you want that top interference to be possible to kind of deform the case enough to get it past, but the bottom one not to be. So you want to figure out, like, with the materials that you've got and the process you're using, what is that sweet spot? And this was a combination of iteration and just like using some numbers that popped into my head because they worked pretty well in the past. But you know, it's not perfect. And in fact here, this bottom snap comes out, as you can see, further than this board. So you have to kind of like snap the board in first. But yeah, and there are a lot of different ways to design these. I think Noe and Pedro have a design they like that's kind of triangular on both sides. Mine is flat on bottom and then angled on top, just because that worked pretty well for this particular case and keeping the top section here both thin and flat on the bottom. So, oh, is that a MediaTek? Oh, Novatech. Oh, I know it's a Novatech chip because we were seeing that on the USB descriptors. So yeah, it's probably a Novatech chip, and this is just their like reference design or something. But that doesn't mean it's a dash cam chip. It just means that like that's a popular application. Usually what you see is on the datasheet, this will just be a system on chip for the imaging market segment or something, and you find it in a lot of different things that have image sensors. Because you need a lot of the same parts for these different applications. That does mean it's likely this is capable of recording video, though. So I'm wondering if maybe there's some other firmware update or some option you can use to enable that. Because these usually only take stills, whereas a dash cam would definitely need to be able to record video. So it's probably got an H.264 codec in there. So yeah, hopefully that helps. Let me know if you have other questions. Yeah, actually that would be an interesting mod. Like if you could find a dash cam with the exact same chip on it and then just use its firmware, I wonder if that just gives you video recording for free. Oh, and you said that, so it supports, it goes up to 50 megapixels, but like that would involve getting a much bigger sensor, right? And finding, I guess there's likely some kind of standard pin out there using. So maybe there are other sensor boards you can find, or you need to make your own breakout. That's pretty. They are NEC/Renesas controllers, each with their own separate oscillator and firmware too. That's interesting. Because like they could have done some clock distribution, they could have shared the firmware, but they didn't. There's a separate firmware and a separate crystal for each XHDI controller, which are these things. And so each controller, it's got a USB port, which is 3 twisted pairs, well, 3 differential pairs. They're not twisted on the board, but they're twisted in the cable. There's D+ and D-, which is the high-speed, low-speed differential pair. And then super speed has a pair of differential pairs for each direction. So you see 3 of those impedance-controlled lanes going to each of these sockets. Yeah, different firmware. That's interesting. That might be handy. And then it looks like the other high-speed connection between here and the rest of the world looks like it goes out to this chip, and then this goes down here. So I'm expecting this to be a PCI bridge. And then here's all the power conversion. Oh, and then that's going to be firmware for the PCI bridge. I don't want to take the heatsink off, but I want to take the heatsink off. I want to see what's under there. Looks like thermal epoxy though, which both might damage the chip to remove, and I don't think I have anything quite as good to reattach it with. I have thermal conductive tape, which is pretty sticky and strong, but not as strong as epoxy. So I'm probably going to leave it there, but we can probably use LSPCI or something to see what the chip is. Anyway, I don't know if I'm going to plug this in on this stream because it's destined for the podcast computer, but I guess we could, right? I mean, I can do computer upgrades on stream. Microscope briefly. So yeah, it's interesting. This one gets power over either SATA or kind of old school connectors. I'm assuming they only use the 5 volts. Because this would need 5 volts at maybe several amps for the external ports, and then 3.3 volts for its own use. So that's firmware for the PCI bridge, probably. I mean, this could be an FPGA. It just seems more likely that it's a PCI bridge, because I don't think they would need to do a custom design for this. Oh, that's interesting. The system on chip in the microscope apparently has face tracking hardware. Weird. There's one of the XHCI chips. Yeah, well now that I have 2 of these microscopes, and I've already started making my own enclosures for them, maybe I'll start making some software modifications for them too. But yeah, I'm happy with this project. Tidy this up slightly. Yeah, look, that would be so in the way originally. Alright, well. Yeah, what do you think? Should we put this in the podcaster right now? That would explain the downtime, right? If folks are watching the stream. Can I still SSH in there? I still remember the password to that machine. I have no reason to remember the password for that machine. Yeah, well, so right now I've got a different card. Has a single Renaissance, UPD, whatever. Oh, the pods are crawling around on the leaves right now. I don't want to reboot the computer right now. I'll probably pick some time when they're not really hanging out, not doing much. But yeah, I suspect we'll see a PCI bridge here, and I can pick that up later. Alright. Let's pop another layer off the stack of things to do, and maybe we can make some progress on that C920 camera mount. Oh yeah, just related to the questions earlier on designing clips. If you tried and you failed, like you've got to just like iterate and refine the design. Getting a snap just right in plastic is really hard to get the first time. You either need to be really familiar with your process and your materials and your dimensions, or you just need to anticipate some trial and error. So make a very small, like make the minimal thing you can to test your snap and then test it. I didn't end up cutting down this design at all because it was not that long of a print, but if you've got a giant thing, you can cut out a little piece of it and just print that. I did a lot of that in the Tuco Flyer project. This would also be an alright stopping point, because I don't want to stream forever, but I could do some more things. Alright, so that's the one that we're basically done with. Yawn, yawn. Alright, and this is the next thing we're working on. This has room for a C920 camera and 2 LED ring lights. I don't know if I should move that ring light further forward. That just makes the whole thing a little bigger, and I would only really worry if these lights were going to like if these front lights were going to cast a shadow in the light from the back lights. I don't think that's going to happen though. Think about where the cables go, just like if any of this is actually what I want. I don't exactly know how the mounting is going to work either. the outer light we're talking about. This came from an old camera ring light. It's just a bunch of cool white LEDs in parallel. Oh, I've got some of these really big IR LED illuminators also, and it looks like I had taken one of them apart to look inside the LED. Speaking of things that might be interesting under the microscope. So this is a very soft encapsulation for these IR LEDs. Yeah, for testing microscopes, really I should get some chip dice out here. It's interesting actually, the working distance goes down as you increase magnification until a point, and then it starts going back up again. Almost got this to the highest magnification. Wow. The working distance is actually not bad. That's like an inch. Find a familiar surface mount part for scale. There's a SOT-23. I think that's a VIA. Oh no, that's the microphone pad. It's a pretty small passive. Oh, I've got some replacement IR LEDs too. These have 2 dice. Do you think that's a transparent top electrode, maybe, but then augmented with those little gold wires to distribute the power across the surface? Yeah, it's actually just two LEDs in parallel. These are some smaller infrared LEDs on the illuminator I'm using. And some visible LEDs. Can't see much through the phosphor. Interesting package though. These are 5mm LEDs. I'm just thinking about how I want all this to fit together. I just don't like a lot of this piece. There's a lot that I don't like about this design. I don't know whether to use self-tapping screws or machine screws or glue or snaps. The board edges are not very accurate on both of these illuminators. They're really designed for screws. The C920 comes with enough screws that I could probably use some of those for the illuminators also. Alright, so how do we want to support this? So there's a ground. This hole right here is actually a grounding hole, which I want to leave clear. Oh, sorry, I'm getting that backwards. Oh, right. The ground was originally over here next to the lens mount, but I moved it because I was trying a larger lens mount and there wasn't room for it. So I've got the ground temporarily attached, not in that hole, but next to that hole. but that's intended to be a mechanical feature, so either way, let's leave it alone. All the area of the board around these edge features, that's clear though, so we can hold it by that area. So that's the whole back side of this board. And I can define just a rectangle that encompasses all the actual components on the board. How's everyone's Friday? Happy Friday. So I'm leaving room for the solder joints for the microphones, even though I'm taking out the microphones, and I might not even leave room for the microphones themselves in this CAD. At least having room in this mount for the solder joints seems like a good idea. There's some surface mount parts right up here to avoid. So this distance really can only be about a ½ millimeter or so. There is definitely a serial port on this camera, at least that's what it's labeled as. TX, RX, plus minus. The shape I'm drawing now should be something that can just come up and meet the bottom of the circuit board. Need more sketch features. Trying to figure out how much clearance I have for these support parts in the back. There's a heat shield over here. Not a heat shield. There's a heat spreader over here I'm trying to avoid. Okay. Oh, this area is really designed for support also. Oh, wait, no, that's where the wire usually passes through. Yeah, the USB wire comes out the front side of the circuit board on a surface mount connector, and then in the original design it passes through that slot to go back out the back end of the case. I don't need it to do that though. I can pretty much just ignore that, but it's also an opportunity for some more support if I needed it. Which, given how close that is to the sensor, maybe that would be helpful. That's like 12 millimeters. 5, 6. It's close. I don't like this weird curve down here. Oh, this whole sketch is terrible already. Oh, thank you. Oh, I should really go. Alright, so that leaves kind of a pocket behind the board to contain the electronics. That's also where we've got the sort of heat spreader that's just kind of absorbing heat. It doesn't really have a good place to put it. If we wanted any kind of ventilation back there, though, light baffling would be important because light getting into the backside of the sensor is not helpful. But I should wrap this up. Seems like a decent stopping point, and I should do other things. I'm really glad this microscope worked. I feel like I should try to enjoy that small victory without worrying about all the other work that's left to be done. Well, yeah. Thanks a lot for everyone who stopped by. I hope your Friday evening or whatever time it is when you're watching this is doing all right. And special thanks to everyone who supports the channel with objects, with Patreon contributions, with friendly words of encouragement and/or uh, you know, less friendly words of encouragement, I guess. I don't know. I don't really mind criticism as long as it helps me find a good path forward. So I really appreciate hearing what you all think, and keep bringing you some interesting projects. I need to do more video editing. I always say that, but I feel like with all the streams this week, it's been nice to actually get a small project from start to finish, but I've got so much footage that I would like to share with more of you that just needs some editing work before I can really do more of that. So, alright. Happy hacking, everyone. I will see you next time.